Now let's start with the second law of thermodynamics. Now there are different definitions for second law of thermodynamics. The first one is that the entropy of the universe is continuously increasing. Moving on to the second definition, all the spontaneous processes, they are basically thermodynamically irreversible processes. The next statement says that without the help of any external agency, a spontaneous reaction cannot be reversed. There is again a definition that states that the complete conversion of the heat into work is impossible without leaving some effect. And the last one says that all the spontaneous reactions, they are accompanied by increase in the entropy. Now let's drive this important relation for competitive exams, that is entropy change for an ideal gas with changes in pressure, volume and temperature. So we can calculate the entropy change by Cv into ln of T2 by T1 plus R ln of V2 by V1, that is equal to Cp ln of T2 by T1 plus R ln of P1 by P2. Now at constant temperature, that is for isothermal process, our temperature will be constant. So this whole term equal to 0. So we are left with the R ln of V2 by V1 is equal to R ln of P1 by P2. Now at constant volume, that is for isochoric process, this term will be equal to 0. So we are only left with the Cv ln of T2 by T1. Next is at constant pressure, that is for isobaric. So for isobaric, pressure will be equal to 0. We are only left with the temperature. Now according to the first law of thermodynamics, delta U is equal to Q plus W, and we know that delta S is equal to Q reversible by temperature. So for isothermal expansion of an ideal gas, delta U is equal to 0. That means Q will be equal to negative of W. We know that W for reversible reaction is minus nRT ln of V2 by V1. Now moving on to the next topic, this is a very important term, that is Gibbs free energy. So Gibbs function or Gibbs energy can be written as G is equal to H minus Ts. Now we can rewrite it as delta G is equal to delta H minus T delta S. Now this delta Ts can be written as T delta S plus S delta T. So for isothermal process, the temperature is constant. So this S delta T will be equal to 0. So we are only left with the delta G is equal to delta H minus T delta S. That is our Gibbs-Helmont equation. Now there is an important formula for delta G of reaction, that is equal to delta G of product minus delta G of reactant. So this will also be equal to delta H minus T delta S. So this is very important to learn. There is again a formula that states that delta G is equal to minus NF E naught cell, where F is basically equal to Faraday's constant and its value is equal to 96487 or approximately 965 0.00 coulombs. And we also know that delta G is equal to negative of useful work or negative of expansion work or negative of maximum work. So Gibbs free energy is that thermodynamic quantity of any system, the decrease in whose value during a process that is equal to the maximum possible useful work that can be obtained from the system. Now there is an important formula for calculating the efficiency of a fuel cell. Efficiency of a fuel cell is equal to eta, and that is denoted as delta G by delta H. So we can summarize the different formulas for delta G as delta G is equal to delta G of product minus delta G of reactant, or delta H minus T delta S, or negative of useful work, or eta into delta H, or minus NF E naught cell, or minus RT ln of Kc, that is basically equal to delta G naught. Now it is very important to learn these points also for competitive exams, that delta G naught is equal to negative for spontaneous process and delta G value is positive for non-spontaneous process, and it is equal to 0 if the reaction is at equilibrium. We have already done that delta S is positive for spontaneous process, negative for non-spontaneous, and 0 for equilibrium. So these points are very important for competitive exams like IIT-JEE mains and NEET.